Hello students, in this video we are going to discuss the analysis of lysergic acid diethylamide, commonly called as LSD. This lysergic acid diethylamide is an extremely potent hallucinogen and it was first synthesized in 1938. It is synthetically made from lysergic acid which is found in an ergot, which is a fungus that grows on rice and other type of grains. This is the general structure. The effects of LSD is called as a tree. It is so potent that its doses tend to be in micrograms. Its effects can be stimulating, pleasurable, and mind altering, or it can lead to an unpleasant, sometimes terrifying experience called as a bad trip. The effects of LSD are believed to occur as a result of alterations in the serotonin system. As little as 20 micrograms can produce a noticeable effect. The effects of LSD typically begin within half an hour and can last for up to 12 hours. Its effects typically includes altered thoughts, feelings, and awareness of one's surroundings. Many users who use LSD see or hear the things that do not exist. It is used mainly as a recreational drug or for spiritual reasons. The LSD is usually found on the streets in various forms, for example, blotter acids. These blotter acids or blotter papers are soaked in a solution of LSD, and these are the most common form of LSD found on the street. The second form of LSD is thin squares of the gelatin sheets, which are commonly referred to as window panes. The tablet form or capsules are also observed on the streets. Liquids are poured on the sugar cubes. Some people may inhale LSD through the nose or inject it into the veins. There is no way to detect or to predict the contamination or which LSD sample contain adult. The LSD can be identified from the street samples by a number of steps. The blotter paper is the most commonest form of LSD which is observed. The process of analysis of LSD blotter acid follows the same general principles and sequences as for the other control substances. The first step is sampling and physical description. Second is the extraction of the sample. Third is presumptive testing. And the fourth step is thin layer chromatography analysis in the LSD identification. The first step of LSD identification is the sampling and physical description of the LSD blotter acids. The first stage in all forensic science analysis processes is a full physical description of the material under investigation. Once the samples to be analyzed have been identified, the physical descriptions, homogenization, and sampling, presumptive testing, TLC, and confirmatory testing should be undertaken. In the case of blotter acids, this includes a count of number of dose units, the size of each of the dose unit, the number and depth of perforations of the dose units, and a note of the pattern and whether it covers all, some, or single dose unit is covered. After carrying out the full physical description of the samples, a particular method can be chosen for analysis and the samples are numbered randomly. The United Nations Drug Control Program recommends the following procedure for the selection of the samples for the analysis. For the sample size up to 10 dose units, all should be analyzed. For the sample size between 11 to 27 dose units, 3/4 of the atoms should be selected at random. For sample sizes in excess of 28 dose units, 50% should be selected at random with a minimum of 21 dose units up to a maximum of 50 units. Once the number of samples has been finalized, now the second step for the analysis of LSD is the extraction of LSD prior to the analysis. As the drug is impregnated onto a paper substrate, it is necessary to extract the material prior to the analysis. Two different extraction methods based on whether the analysis is qualitative or quantitative is followed. For qualitative analysis, the extraction is done by mixing the test sample for 30 seconds with the sufficient quantity of methanol to achieve a sample concentration of 1 milligram LSD per ml. Alternatively, methanol water mixture can also be used to extract the LSD more sufficiently or more efficiently. Any solid material should be removed from the extract which can interfere in the chromatographic analysis, and this can be achieved by filtration through a 5 micromolar filter paper. If the quantitative analysis are to be carried out, it is necessary to completely extract the LSD from the paper. This can be achieved by suspending the material in a large volume of 1% tartaric acid solution in a separatory funnel. The mixture is extracted 3 times with an equal volume of chloroform, and then the aqueous layer is basified with 1 molar sodium bicarbonate. The resulting mixture should be extracted 3 times with an equal volume of chloroform, and the chloroform extracts combined, filtered or centrifuged and evaporated under a stream of nitrogen. The residue which is obtained after extraction and evaporation, it should be then dissolved in a known volume of the solvent. Once the number of samples are finalized, then the sample is extracted by using a suitable procedure based on the qualitative or the quantitative analysis. The next step for LSD analysis is the presumptive testing. The two tests are commonly used for identification of LSD in the sample by presumptive testing. The first test is for fluorescence test and the second is a chemical test. The one of the properties of the LSD that can be utilized during the identification process is its fluorescence. In such a test, the original dosage form or a drop of the methanolic extract from the dose form is placed on the filter paper and it is allowed to dry. The material is then observed under a long wavelength UV light, and if LSD is present, a blue fluorescence will be observed. Along with the sample, the negative control and the positive control can be utilized for comparison purpose. The negative control will demonstrate that the fluorescence, if observed, is due to the drug extracted into the methanol. And the positive control will provide a reference color reaction and gives an idea of the fluorescence that might be. Second test for the identification of LSD from the sample is the chemical test. The classical presumptive test for LSD is the Elrich reagent test, and in this test 1 gram of paradiethyl aminobenzaldehyde is dissolved in 10 ml of orthophosphoric acid, and a small amount of this reagent solution is then added either directly to the test substrate or to the extract to be tested, and any color change is observed. If a blue or a purple color develops, then the presence of LSD may be suspected and a confirmatory test should be carried out. The confirmatory test will be carried out either by using TLC or the next step of analysis for LSD is thin layer chromatography. Following the possible identification of the presence of LSD, the next stage in the analysis is the use of thin layer chromatography. This is employed because it cannot be used to prove the identity of LSD. It can be used as a rapid, cost-effective method to eliminate those samples which gave a positive color reaction in the presumptive test, but which do not contain this drug. These will be rarer when blotter acids are suspected, but may be more common where other substrates have been used as the carrier medium for the LSD itself. In TLC or in chromatography, a mixture separates because of the components of that mixture have different affinities for the two phases. The extracts are prepared by mixing the test sample with sufficient methanol for 30 seconds to achieve a sample concentration of 1 milligram LSD per ml. The activated silica gel plate containing a fluorescent dye are used as a stationary phase for TLC. The material to be tested plus positive and negative controls are spotted onto the plate and the chromatograms developed in the normal way. The solvent systems which can be used include a mixture of chloroform and methanol or a mixture of chloroform and acetone. After chromatogram is developed, the plates are removed from the chamber. The solvent fronts are marked and the plates are observed under short and the long. Under the short wavelength, LSD will appear as a dark spot on a light background, while in long wavelength it will appear as a bright spot on a dark background. The RF value or the retardation factor of the sample and the positive and the negative control is measured, and the chromatogram should then be developed with the enriched reagent with which indole alkaloids, which includes LSD, react to give a purple product. If a product gives the same results, that is the same retardation factor or RF value and the same color reaction as LSD under all of the conditions described, then only the further confirmatory tests will be carried out. This is a typical TLC plate for LSD in which we can see the purple colored spots. The confirmatory test for the presence of LSD can be carried out by any sophisticated instrumental technique. Since there are a large number of materials which will produce the same results as LSD in one or more of the screening tests, it is necessary to confirm the presence of this drug by using an instrumental technique. Out of the methods available, HPLC with fluorescence detection is the most commonly used, but the gas chromatography technique and FTIR are also used as a means of quantifying LSD. The HPLC analysis of LSD includes two methods. The first is an ion separation technique and the second is ion paired method. And the majority of the techniques that are uses the same physicochemical characteristics and the system, the basic requirements are described. The first method is reversed phase method using the HPLC system and the conditions are as shown in the table. The column which is required for LSD analysis is of octadecacylene of length 10 centimeter and 4.6 millimeter inner diameter with the particle size of 5 micrometer in size. The solvent system which is used for HPLC is a mixture of methanol, ammonium phosphate at a pH of 8. The flow rate is 1 ml per minute and the detector used is the fluorescence detector with the excitation wavelength of 320 nanometer and the emission wavelength of 400. The second method of HPLC identification is an ion pairing method and the conditions which are used for the setup of the instrument are shown in table, and this system is not as specific as that employing fluorescence detection, although it is included to illustrate the separation mechanism. The identification or the confirmation of LSD can also be done by using gas chromatographic technique, and the basic requirement for the gas chromatogram or GCMS instruments are as in the table. The column required is of BP 5 and the length of the column is 25 meter and the inner diameter is 0.2 millimeter. The injection temperature is set as 270 degrees Celsius, whereas the column oven temperature is 100 degrees Celsius, rising at 24 degrees Celsius per minute to 270 degrees Celsius. The detector which is used here is a mass spectrophotometric detector. On the contrary, the LSD can also be identified by using microscope FTIR spectroscopy, which is a very simple and more accurate technique. The more recently, it has become possible to identify LSD in samples without the need for extraction of the drugs. In this technique, LSD blotter acid is described and then subjected to a simple extraction procedure followed by microscope FTIR spectroscopy directly on the extract. For the identification or for the confirmation of LSD by FTIR, first, the blotter acid paper is soaked in water for 1 second, which will swell the fibers of the paper and was found to facilitate the extraction of the drug for further analysis. The excess of water was then removed from the blotter and it is heated to 120 degrees Celsius for 1 minute. Then a mixture of dichloromethane and ammonia was added to the blotter paper which will dissolve the LSD, and this extract or this solution will be now transferred with the help of microsyringe on a KBR disc and its spectrum. The IR spectrum was obtained by scanning in the wave number range 700 to 4000 per centimeter with 30 scans at a resolution of 4 per centimeter being collected. The obtained spectra were compared with the standard to confirm the presence of LSD in the sample. And here the spectra A is of the standard compound LSD, that is lysergic acid diethylamide, and the spectra B is the spectra of the sample. And we can see here that the peaks are exactly identical. These peaks are the spectra of sample as well as the standard shows the peaks at exactly the same wavelength, which indicates the presence of LSD in the sample. So in this way, the LSD can be easily identified from the blotter papers or the street samples and it can be reported. For the detailed notes of this chapter and the question bank, please follow the link which is provided in the description box. Thank you and see you in the next video.